Okay, welcome to the second half of week 6 here. I've got a reduced amount of stuff to cover today, and this is all about manipulating strings. We've done a fair amount with manipulating strings. We've seen that you can slice strings, and you can concatenate strings, and you can iterate through strings, and so on. In this chapter, I want to fill in some more of the details of things that you can do with strings. We will have a quiz starting in about 44 minutes from now, and I have my timer here set to remind me to shut up when the time comes. Any questions before we begin? Now, I will mention that unfortunately I somehow lost the video from Tuesday, so I just don't have that to post. But if you step through the NumPy material, the part 1 and part 2, and just try each thing out for yourself, and try a slight experiment, a slightly different version of what's being discussed, that would actually be very good practice for the, for getting ready for the final exam. In fact, that applies throughout the course. If to get ready for the final exam, a really good idea is to not just read through the slides, but instead read the slide and try a slight variation of what's shown on the slide to see whether your understanding is really correct. And if you do that, I think you can review the material thoroughly and be in good shape. Yeah.
I have a Mac. Did anyone figure out how to work NumPy on Apple computers?
Yes. How did we do that? We figured out it would work in Spider.
Oh, okay.
So Spider, you can launch Spider from the Anaconda list of, the matrix of applications that you see. And Spider is pretty nice. It's basically like having a file and a shell just side by side, whereas using idle, I sort of have to toggle back and forth between them. And I don't like to use Spider to teach from because the font is so tiny, it's hard to see anything. But Spider does have the ability to access NumPy. Any other questions? Okay, so let's get into this. So we've seen already that you can use the plus symbol between two stir objects, two strings, to concatenate those together. You can use the star symbol, the multiplication symbol, to create a repetition of strings. So if I have S1 gets hi plus world, I now have hi world. There's no space that gets put in there by default. You just have to, if you want a space in there, you got to remember to do it. And if I say S2 gets S1 times 4, then S2 is going to be hi world in sequence 4 times. Okay? We can index a particular item within a string using one integer subscript and square brackets. We can also create slices from strings in the usual way. So S2 sub colon 2 means to give me a slice from that string up to but not including the first W. That's the item sub 2. So I'm going to get hi as the result of that slice. I can split. Oh, I made a mistake in my example. I see that there ought to have been a space in hi world, so let me fix that really quickly. So S2 gets hi space world times 4. All right, so now we've got some spaces in there. And we know that you can split a string at some character that you specify as an argument. And what that will do is to create a list of the strings separated by that split string. All right, so here I have a list of 5 stir values from splitting S2 at whitespace characters. So that's all things we've done before. Everybody okay? All right. Now, there are a ton, I say numerous here because when I write things down, I try not to get carried away. But when I speak about them, I get carried away. So there are boodles of string operations that you can execute to modify and retrieve parts of and search for stuff within strings. And this is all in the online documentation as shown at that URL. For example, let's suppose I have a string. This is a test. Whoops. This is a test. If I say s dot capitalize, that's just going to convert the first lowercase letter in the string to uppercase. It does not actually change s. A string is, of course, immutable, but what it does is to give me back a copy of s with the first letter changed to uppercase. All right, so s is still what it was, and if I wanted to save a capitalized version of s, I would have to create some new variable, or I could create some new variable to refer to that capitalized copy. Seems like an awful lot of work to have to type out capitalize just to get the first character turned to uppercase. Oh well, I didn't design this. Another sort of strange one is title. If I say s.title, that will go through and convert each first letter in each word to uppercase. Seems to me that that has some limited applicability, but there you go. You can also convert all of the uppercase letters in a string to lower. All right, well, I said this absolutely backwards. You can convert all of the lowercase letters in a string to uppercase with .upper. And what I was describing is you can convert uppercase letters to lowercase with .lower. So here's s, and if I say s.upper, all of the letters get converted. Now notice that the spaces don't get converted, only the letters get converted. And if I have some combination of upper and lowercase, and I convert those to lower, then everything becomes lowercase. All right, so those 4 methods, capitalize, title, upper, lower, manipulate the letter case of letters. If there were digits in these strings, 0 through 9, or punctuation marks in these strings, then those things would be left unaffected. I can widen a string by putting space around it, or by putting some arbitrary thing around it, using a variety of centering and left and right adjusting methods. So here I have s containing world. If I say s.center and specify a field width of 10, well, this is going to give me back a copy of s centered within a string that's 10 characters wide, where by default spaces are used as the fill characters. So in fact, I'm going to get back a string containing 3 spaces, and then word, and then 3 more spaces. Okay, so the length of that really is 10. There are exactly 6. There are exactly 6 spaces in that resulting string. Let me capture that output into S2. Okay, so S2 now contains word with space on either side of it. Relatives of center include Oh, I'm sorry, I got one more thing to say about center first. I can say s.center, okay, there's s. I can say s.center and use something other than a space as my fill character. So here I'm going to specify a 10-character wide field, but let's say a plus symbol as opposed to the default space as my fill character. Of course, you could use a dot or a dash or any other character that you like as the fill character around that word. All right, we can both left justify and right justify strings within fields of widths that we specify. We can say s dot rjust 10, and by default we will get we will get word right justified. Right justified from your perspective. It's right justified within a field 10 characters wide. And ljust does the opposite thing. And you can specify a fill character if you wish. And instead of spaces, you'll get the fill character. All right, so here I have word left justified with 6 dots following it. Good. I was going to make a joke that I had brought lunch for everyone and you missed it, but no, that's a bad joke. I didn't actually do that. All right, so I've got S2 here, which is this string containing word with 3 spaces on either side. Let me say s gets s2.copy. Attribute copy. S gets, oh, that's fascinating, S2. I don't want to have S and S2 refer to the same object, so let me say S gets S2. I'm going to request a slice of S2 consisting of all the characters from the beginning up to the end, and that will give me a copy of S2 even though there is no named copy method. All right, so I can discover that S's ID and S2's ID are... No, this makes sense. This makes sense. I had forgotten this. Short strings are sort of like small integers, and if you have a short string in memory, then if you attempt to create a copy of that short string, well, Python is smart enough to recognize, well, it's really still the same string, so I don't have to store 2 copies of it. And it's immutable anyway, so if I change the string through S, that also changes the string through S2. Well, I can't change the string through S. All right, well, I'm I'm confusing myself now. So S is S2. And both of these things are references to the string of 10 characters, word with 3 spaces on either side. All right, now we've seen the strip function. I'm pretty sure we have, haven't we? And what strip does is to eliminate the whitespace characters from both sides of the strings. You can also specify that you only want to strip from one side or the other with lstrip to strip the left-hand spaces, or rstrip to strip the right-hand spaces. Now, spaces are obviously spaces, but it turns out that any so-called whitespace character will be stripped off by these various strip functions. And that includes things like newline characters, tab characters, form feed characters, which you used to actually see in programs, but you pretty much don't anymore. Carriage returns, vertical tabs. So if I say S2 gets some combination of whitespace characters, there's a new line, there's a tab, there's a couple of spaces, there's a carriage return, and here's a form feed, and another space, word, space, space, new line, tab. Okay, so there is how S2 is represented in the machine. Now that's, oh, okay, so the form feed is being displayed to me using its hexadecimal representation, which is hexadecimal 12. C in the digits place has a value of 12. If I print this thing, it's going to look pretty strange. Okay, because print is going to process the new line to drop down to the beginning of the next line, and then the tab to go in, and then the 3 spaces, and then a carriage return to go back to the same line, and then a space forward, and then the form feed is going to whip everything off the top of my screen. So, oh, interesting. Ah, interesting. Okay, so on this system, I did not have everything whip off the top of my screen. Instead, I got one of the so-called extended ASCII characters, this little rectangle thing. Well, I guess it's an up arrow or a rectangle, depending on whether I'm highlighting it or not. Okay. But if I say s2.strip, all of that stuff goes away. Spaces, tabs, carriage turns, new lines, form feeds, all get stripped off. Now, I just want to make a remark here. If I say something, if I read a line of input from a file, the line comes in looking something like this. This is a test input line, and we know it has a new line character at the end when I read it in from a text file. Now, in my examples, to get rid of that new line character, I have said, let me leave line alone. Let me say line 2 gets line up to but not including the last character. Okay? Now, a lot of people will instead use the strip command. But the strip command can strip too much stuff. If you are processing lines that begin and or end with white space, let me say line 3 gets. Okay, so this is a line from a text file containing a Lewis Carroll poem from Alice in Wonderland. It's an 8-line little poem called How Doth the Little Crocodile. And here I've got a couple of spaces at the beginning and I've got a couple of spaces at the end followed by the new line. Now if I say line 3 dot strip, I've actually damaged the indentation. I've lost the indentation. And so this is why my personal preference is to say line 3 sub colon -1, so that I do get rid of that new line at the end, but I don't get rid of any of the other white space that might occur at the beginning or the end. Okay, so that's just a comment to understand or no. Any questions so far about any of this? Okay. Well, now I'm going to have S set to refer to fantabulous. I seem to have a habit of creating examples that are hard for me to type. I don't know why that is. There are a bunch of so-called predicate methods. Yes? Oh, that's an excellent question. That's an excellent question. Yeah, good question. Let me create S3 of all right, so here I've got S3 with a whole bunch of white space in it. If I say S3.strip, strip only affects the leading and trailing white space. So the leading spaces here were stripped off, and the trailing spaces, tabs, and new line were stripped off, but all of the other white space in between remains unaffected. Good. Okay, excellent. We use replace. So remind me again when we get to slide 14, and I will show you. Okay. So we've got S now referring to fantabulous. And the string collection of methods provides a bunch of so-called predicate methods or testing methods that allow me to test attributes of the string. For example, I can ask whether S is alpha, meaning are all of the characters in that string alphabetic? And that's true. I can ask whether S is numeric, and that is not true. There are certainly characters in there that are not numeric. I can ask whether S is upper, and that's false. The characters in S are not uppercase. But if I ask whether S is lower, that's certainly true. Okay. Now I can ask whether a string is alphanumeric. That is it a combination of letters and digits? Let me use the example shown here. S gets catch 22. And if I say S dot is lower, this is false. Oh, it's true. Because the digits don't count. All right. I was going to say, and I guess I will say here, that all of these functions are sort of stolen from the similar library functions in the C programming language. Guido, who developed Python in the first place, is an expert old-time C language programmer, and in fact, Python itself, the Python shell, is a C program, right? So the Python language, it's not required, but the Python language, as most people use it, is actually a program written in the C language. And so he made available a lot of these so-called C-type, character type functions from the underlying C library. But for some weird reason, he changed the meaning of a few of them, which trips people up. So had I been in writing a C program and I used is lower, I would have gotten a false when the digit got hit. But here I'm getting a true. S dot is upper is certainly going to fail because there are no uppercase letters in there anywhere. S dot numeric is numeric, excuse me. Also fails because there are things in there that aren't numbers, but is al num succeeds. Okay. Another thing that I find peculiar about these functions, since you're not C experts, you won't know or care, but I'll show you an example. If I say S gets hello world, and I then say S dot is lower, here's another case where in Python this is considered to be true because the space is ignored, whereas in the C language, in the original implementation of is lower, I would have gotten a false when the space character was encountered. I can also ask space tab, new line, carriage return, form feed, vertical tab, dot is space. And all of these characters are represented as white space characters. So that's true. But if I said 5 dot is space, I'd get a false. All right, so these are very good tools to know about for processing user input, where you ask the user to enter some input, they type some stuff in, and then before taking whatever they type and trying to convert it to a floating point, you can do a test. You know, is this thing numeric? And if it's not numeric, then you can bail out. Now the problem there is that although, and here again, this is a puzzler for me. A space is considered okay in a number, but a dot is not. So what can you do? Well, what you can do, it just occurred to me, is you can say m gets 5.6 dot split at dots, and then you can say for s in m, and I'll just print these out. S dot is num, is numeric. Okay, so I can expand my test a little bit to say, well, if what I get in, I split up at periods and all the parts of numbers, all right, well, maybe this thing is actually a floating point number. And then I can try to do a conversion and hope that an exception doesn't occur. There's even a test that I can perform as to whether a particular string is a valid Python identifier, like for a variable or a function or a class. So Route 66 passes that test. Is identifier, whereas 23 skidoo does not, because it starts with digits. All right. It's okay for there to be digits in an identifier, but they have to be after the first character. So these are historical strings. Route 66 used to be the highway between Chicago and Los Angeles before the interstate highway system was developed starting in the 1950s. And there was a show called Route 66, and there are still people who visit parts of Route 66, and there's parts of Route 66 that are completely covered by sand. Anyway, so that's what Route 66 is about.
Have you ever seen Cars?
I'm sorry?
Have you ever seen Cars?
The movie Cars, they're that's right. They're traveling down parts of Route 66, aren't they?
Yeah. Well, they're on it, and then they lose their whole town kind of goes under.
Oh,
Yeah.
cool.
Yeah.
See, I have to remember these Disney movies better. Yeah. I'm sorry?
What do you mean by identifier?
Identifier as in a valid name for a variable or a function or a class in Python. 23 skidoo is another sort of odd thing, which I know for some reason, but I'm not old enough to know it. It was apparently one of the most popular slang terms about 100 years ago for meaning let's get out of this place. It was in the early 1900s sort of what the word groovy was in the 1960s. You know, everybody was saying it all the time. You don't care. Okay, so 1234.isNumeric returns true. I can even test whether something is a valid title, and that will be true if each of the first letters of each word is an uppercase letter. In this case, it's false. This is a test, just has one capital T. Now, we've seen split for splitting a string into a sequence of items in a list. The join function is the opposite of split. The join function takes an iterable of strs, whether that's a list of strs or a tuple of strs or a set of strs, and joins those together into a single string. The usage of join looks kind of backwards. All right, so let me create a string first. This is a test. And then, s gets. This is a test. And if I then say m gets s dot split at spaces, which is the default anyway, I now have a list of 4 strings. And you might think, well, now I just say m dot join those guys together, but rats. No, because join is not a method that belongs to the list data type. Join is a method that belongs to the string data type. And so this is why I say the usage looks kind of backwards. What you have to do is to give the string that you want to join around first, and then say dot join, and then your iterable containing the strings that you want to join together around spaces. All right, so I'm saying space dot join m, and I get back this is a test. So that space character is plunked in between each of the 4 strings that are contained in the list m. Now I can join around any string that I want. So I could say equals equals, let's say, dot join m. And now I get the contents of m joined around double equals. If you like comma-separated value information, you can join around commas. All right? So join is really cool for taking tuples of things, lists of things, sets of things, and hooking them all together into a string around some join string. All right, you can examine a string to find out how many times it contains a particular value or a particular. I know I can talk. I've been doing it for years. How many times a string contains a certain character or a certain sequence of characters. So if I say s.count t, I get told that s contains t 3 times. If I say s.count is, all right, I can search for a string of multiple characters rather than just one. And this is a test, contains is twice. We've got it here and we've got it again here. As opposed to just counting how many times a certain string occurs within a string, I can actually use the find method to discover the starting location of some string within my current string object. All right, so s is still, this is a test. If I say s dot find a t, this will find for me the index of the first little t within s. And of course, the first little t is at index 0. It's the very first character in here. Okay? Now, if that's not the one that you wanted, you can use find with another option, which is the starting location where you want to do the searching from. So if I found a t at location 0 and I don't want that one, I can say, oh, well, let me find a t starting from sub 1 instead. And I discover the next one is at position 10. Does that make sense? Okay, 0 through 5, 6, 7, 8, 9, 10. Yes. So sub 10 is the second t, and then s.find t starting from 11. All right, there's another t at position 13. I can look for more. I can say, all right, let's check past that. And now I get -1 in the case of the find method is considered an invalid index. Okay, in fact, the Here's S, and the length of S is 14 long. So the valid indexes in this string only go from 0 up to 13. So if I try to find another t starting at position 14, that's going to fail for sure. And if I say s.find a z, that also fails. There's no z's in that string at all. I can look for substrings. I don't have to look for just individual characters. So if I want to look for the pattern is, that works fine. I can also go backwards. I can say s.rfind s, let's say. And I discover that the last s, maybe s.rfind s was not a great example, but I discovered that the last character s in the string s is at position sub 12. Okay? Okay. Any questions about what's going on with find or rfind? Yes?
I tried that I can use s.find to do a slice.
Yes, you can. Yes.
But like, what if I want to return s slice first s to third s?
Okay. First s to third s. All right. That's not trivial. Finding the first s is trivial. I just say s.find s. And I find that there is an s. Now I can find the second one by saying s.find s and one more than the first one, and then I can find the third one with s one more than the second one, and so that gives me the indices of the sub 3s and the sub 12s. What? Remind me again, what was your question? If I remember your question correctly, I think you have to know the answer to your question to find the answer to your question. Ask me your question again.
I want to do a slice
Oh, you want to do a slice?
and use s.find.
Okay. Okay. All right. This is going to be great. Okay. S's. S's is my list, and it's going to be a list of the indexes of S's. And I will say, actually, let me, rather than doing that, let me say S's gets, let me initialize S's with s.find s. So S's contains a 3. That's the first S. And now I can say while s sub minus 1 is not equal to minus 1, that is, while the last item in the list, oh, sorry, that's S's, not S. So while the last item in S's is not a minus 1, I'm going to say ss.append s.find s ss sub minus 1 plus 1. I told you it was going to be great. All right, so S's is my list of the indexes of the S's. And I'm going to initialize SS to contain the index of the first S. Now, that might be minus 1. There might not be any S's. But I'm saying while the last item in S's is not minus 1, let's look, starting at the next valid position, to see whether there's another S later on, and if there is, we'll append the index for that one. All right, and so when I hit enter here, S's gets filled in with the index of all the S's. And now I can say S sub SS sub 0 colon SS sub 2. Because you wanted to go from you wanted to use the first one and the... Now, did you want to use the third one as the value past the end or at the end? In other words, this is going to give me, okay, so here's my string. S is this is a test. And my question is, do you want this, S is a T, or do you want S as a test? S as a test.
I want the latter, just plus one.
Correct. So I just add one here. Okay, that's a good question. But the problem with -2 is that you're making an assumption that the second S is the second character from the end.
Not that, but SS0 colon SS2 plus 1. If we don't know that there are exactly 3 indices, we can say SS0 colon SS minus 2 plus 1.
Oh, well, yeah, that's true. I am taking a risk. I am taking a risk here that there are at least 4 items in my S's list. I am taking that risk. Okay. We can replace characters with other characters using replace, and I promise to do this. So where's my S3? S3 and all this stuff. I can say S3 dot replace space with two spaces with one space. This is kind of awkward. I really should be using something called regular expressions for this, but that does change each occurrence of 2 spaces to 1 space, and I can sort of whittle away at my spaces using replace. All right, the rest of this is a lot more details of the format function. We have already talked about the format function, so it's not too tragic that we didn't get here. But I do recommend that you read through this and try experiments, because knowing how to cleanly format output is a boring but extremely valuable skill to have. It impresses people when the output that you produce looks good. All right? All right, so I will shut up now. The quiz should become available in about 1 minute. And so it's on Canvas, so go ahead and get yourself set up and start when you're able. You have half an hour. Open book, open system, open web. No talking to each other. That's, the usual rules.